I have a new exciting project that I want to share with all of you. Unirack is an audiovisual modular synthesizer and uses pure data for sound generation. Unirack actually does not require you to do any patching because it will generate a patch automatically once you load certain assets into its main script, which is the UnirackInstance script. So it will allow you to load a sequencer, a instrument, what I call an instrument, which is a sound generator, pretty much, can be pitched or unpitched. And then you can have a sound process step where you can load many different assets to do, for instance, an ADSR envelope generator, a filter in this case, and a channel control process. And then you can also have auxiliary channels. And for instance, for this particular configuration, where I have a topograph sequencer, which is a particular kind of sequencer, and then I have a pitch quantizer, I have a velocity quantizer, I have a sound generator, and this is one, but I have many in Unirack, and they're continuously being added to it. Then I can have the polyphony into this patch, and this configuration will generate automatically something like this. So all of the assets that I have loaded in the patch build section of the UnirackInstance script will be reproduced in PD and automatically connected. The user does not have to actually patch anything, just needs to choose whichever modules they want to add to the patch. And you can see how the patch build feature in Unirack actually does the connections based on the type of block that it's loaded. The sine saw FM block, it will be reproduced here, and whenever a envelope generator is encountered, it will be connected with a multiplication, which is the way to apply an envelope to a sound. And then from there I have a resonance filter, and then a channel control, and eventually the channel control, which has some sense, will send it to the auxiliary channel, the auxiliary process, which is a reverb in this case. And the note in objects in PD and the DAC tilde object are automatically added and connected. And you can see how pitch is automatically sent to the sound generator, while the velocity is automatically connected to the envelope generator to give you different velocities for the envelopes. One important aspect of Unirack, and this is a deliberate choice in the architecture of the software, is that almost all control data is generated outside of PD. The pitch quantizer, the sequencer, the velocity quantizer are handled by Unity outside of PD. What that means is that a sequencer will run at frame rate, which implies that for Unirack to be accurate, it will have to have a run on a good frame rate. But that's true for all game design projects. One needs to make sure that the frame rate is always kept at a certain standard. but in my experience, running things at 60 FPS, as far as musical events are concerned, is perfectly satisfactory. Same thing for objects like LFOs. LFOs in Unirack run at frame rate. Why did I decide to use control data as generated by scripts? Because the goal of Unirack is to keep all of the control data into Unity so that it can be sent to either sound patches or visualizers. So I can use the same control data to control sound generators, PD patches, sound processes, and control, for instance, shader parameters. So in Unirack, I have three kinds of scriptable objects, of Unity assets that I can instantiate. One is the rack module, which is control data. So that will be sequencers, LFOs, pitch quantizers, velocity quantizers, random number generator, all of the control data that you might think of that exist in software like VCV Rack can be found in Unirack. Then there is the PD block asset, which is an asset that is meant to send parameters to the patch that, again, it's automatically generated. So you will have a PD block, for instance, for each one of these modules. So I will have a PD block that controls the sine saw oscillator and have all of the parameters of this block. You can see that there are no inlets for parameters. Those are implemented inside of the block and they're sent automatically from the script. So this will have for instance, the detune parameter, a gain parameter, a FM ratio parameter, an FM depth parameter, etc. And this will be controlled by the script that it falls under the category of the PD block. Then I have a VI module, which is for visualizers, and this will also have parameters that are sent from the inspector, such as, for instance, the positions, the colors of the object in this visualizer. And every visualizer will have different parameters, and all parameters will be visible in the inspector through sliders. Very important is the patchbay system, which is unique to this to Unirack, and this probably was the most complex thing to develop in Unirack, meaning that I have an asset that will load a tuple of objects. Let me navigate down to this. So I can load a target module. I can load a controller. So the controller will always be a control data asset, such as an LFO. So of course in Unity, I cannot do cable connections like I do in VCV or other graphic programming languages, but I can have drop-down menus and I can map, so I can map that output to the parameter of the target module. Not only that, but I can also scale the lower limit and upper limit of the input of the output to the parameter. So this is the simple patchbay that allows me to route a control data to another control data module. I can also have a patchbay to send things to PD. So in this case, I'm routing a sequencer to a VCF, so to a filter, and I'm using the ramp of the sequencer. So the sequencer has a ramp that goes through the different steps, like a sawtooth ramp, and I can map that to the cutoff parameter. In this case, the VCF will have resonance, cutoff, gain, dry, wet, all of those parameters that will be showing in this drop-down menu. You can see how the patchbay have these fields. So the target module and controller module is where I can load the different assets that I want to connect. And I have a polyphony field because each module can handle polyphony. Of course, monophonic will just mean polyphony 1. In this case, I have 3, which means that there will be 3 instances of the VCF filter, and each of the instances will be controlled by the 3 different outputs of the controller. So that means that the controller also will be set to polyphony 3. And you can see that for each polyphony channel, I have scaling options for each one of the connections. And for the Patchbay VI, I still have a control data module that is mapped, in this case, to a VI module. The VI module will have its own parameters to be controlled. In this case, for the Patchbay VI, I also have a easing function option because for visuals, sometimes you want to have a more nuanced way of mapping things, and in this case, it's using a spring easing function. And I also can, for instance, invert the sign of the output to produce a different kind of effect. So the Patchbay VI has a little more features because the visualization sometimes needs to be a bit flexible to achieve what you want. The last thing I want to mention as an introduction is the UI windows that I have created for this, which are very useful because, again, the goal of Unirack is to streamline the audiovisual composition process. And to do that, it's useful to have, for instance, all of these objects, all of these assets that I have loaded onto the UnirackInstance script presented on one single window. The module manager is where you create these assets, these modules, and I use this method where all modules that are created can be assigned a name based on the scene you're working on. So thank you for watching. Just so you know, this repo is not public yet. If you are interested in be a beta tester for Unirack, if you would like to know more, feel free to get in touch with me at this email. And until next time, take care.